Hello everyone, my name is Aklesh Teli with student ID number 2024190223. I am integrated master and PhD student from Congo University under the supervision of Jiyong Park. Today I am going to present a book of practical RF biosensor chapter 6, that is photometric application. In our presentation we include introduction to the technique for optical sensor, visual observation spectroscopy, and we will follow on fluorescent reagent. Then we will capture also indirect method using competitive binding, and also we will include reflectance method, internal reflectance spectroscopy, light scattering technique, and at last we will conclude our presentation including optical sensor application. So today the first topic is technique for optical sensor. Optical sensor is also photometric sensor that are operated in two modes, extrinsic and intrinsic. In extrinsic mode, the waveguide acts as a both light source and a collector, and it's absorb of light and is described by the Beer-Lambert law. It is also proportional to the measured intensity and the thickness of the sample layer. In the extrinsic mode, the measurement acts directly with the light in the waveguide phase, and polarization and intensity may be modulated within the guide. In the first figure, it is the schematic of a inline solid state optical sensor. Here we can see the light incident and then it passes through the optical clear membranes. Now the visible absorption spectroscopy. As we mentioned, the visible absorption spectroscopy is measure the is distinguish the acid and base on the base of this pH. So the pH is the fundamental for visible absorption spectroscopy. Many dyes are used for the pH, but they are very low range, so it's only measure up to 7 to 7.5. Here methyl red is suitable pH dye for acidic and basic distinguished visible. The detections are originally made at 558 nanometer, that is reference to the 600 nanometer range, between the range of 7 to 7.5 pH. In our right side figure, you can see there is the visual distinction between the base and the acid. Now the visual absorption spectroscopy measure of ammonia. The pH probe with the higher pH response is needed for the ammonia sensing. So the 4-nitrophenol suitable indicator for the ammonia. Oxygen perchlorate dye coated on a capillary waveguide and operate in the instincts mode for the ammonia detection. On also figure we can see there is optical fiber that is coated with the oxygen perchlorate dye. So a few of these systems have been developed into a biosensor for penicillin and urea also. Now the fluorescent reagent. Most developed area. This is the most developed area so far for the photometric sensor and biosensor. Trisodium 8 hydroxy 136 trisulfonate is the best fluorescent reagent for the detection of a photometric sensor and a biosensor. And acrylium and quinidium based fluorescent reagent are base for the halogen material like chlorine, bromine, and iodine. 2 hydroxide, 1 and 3 xylol, 18 crown, 5 with dizoate, 4 nitroaniline immobilized at the end of an optical fiber of for potassium. Peril- Perilene butyric acid on a polyacrylamide for oxygen sensing, but sometimes other acids are also used to sense the oxygen. Now benzofluorethane responds to the sulfur dioxide, but it is very low, that is 84 ppm. Now indirect method using for competitive binding. Competitive binding method is used if neither the analytical nor the reagent are used for the sensing or show the spectral change on binding. So for that, concanavalin A is a suitable reagent for the glucose sensing. The FITC dextran is fairly mobile inside the optical cell and can also detect the glucose. In the figure, we can see that the fluorescent dextran are used for the sensing of the glucose. Now the reflectance method using for the sensing internal reflectance is spectroscopy. In order to the reflect light totally within a optical fiber, there need to be a zero flux of energy in the optically rare medium. The evanescent wave field decay exponentially with the distance from the waveguide interference to interact with the molecular species that are present. Reflectance method. How the reflectance method are used for the sensing. These methods are very concerned with the study material it's absorbed on an optical surface and are particularly suitable for use in immunoassay. For this method, we use the three different types, that is attenuated total reflectance, total internal reflection fluorescence, and the surface plasmon resonance. So these are the three methods that used for the reflectance method. Now the light scattering technique that used for the sensing. With the application of this, we use the laser light and has revolutionary used the light for scattering technique. They are the three relative, and these are the also new technique and powerful technique for the sensing. Quasi-electric light scattering spectroscopy, photon correlation spectroscopy, and the last is the laser Doppler velocimetry. Quasi-elastic light scattering spectroscopy is actually the assembly of the particles suspended in a medium that's move under the Brownian motion and different way in which the light is scattered from each particle cause a fluctuation in the relativity with the time and distinguish contain information about the size and the size distribution of the particle. Now the photon correlation spectroscopy. This technique is really an extension of a QELS, the previous technique. This usually decays the exponentially with the delay time, which is related to the size of a scattered particle or microparticle. And the last one is the laser developed velocimetry. This technique is used to obtain the information about the velocity of the particle flowing through the tube. Laser Doppler velocimetry has been applied to study for the living cell. To conclude our presentation, we discuss about the application of the photometric techniques to the sensor. We cover the optical fiber waveguide, which can be used in either extensive or intensive mode. We talk about the pH, fluorescent and the absorption method are also compared. We talk about the methyl orange for the direction about the acid and the base that range from the pH of 7 to 7.5. And also we talk the principle of the reflectance method. They are the three, that is the total reflectance, total internal reflection, fluorescent and the surface plasmon resonance. For the light scattering method we talk about the three, that is QSLC and photo correlation spectroscopic, and the last we talk laser Doppler velocimetry. Thank you all.